Howdy folks, Doc here with Last Best Tool, and well, here it is. This is the Magnesium Baton 3 Pro Max by Olight. They made a magnesium flashlight, and you probably had the first thought I did, like, you've got to be kidding. Magnesium? But in reality, you might be driving a car that has, a magnesium body panel set, maybe part magnesium on the frame, a magnesium engine block, potentially magnesium wheels. That's really common. So a magnesium flashlight, no problem there. And it's all an alloy too. It is not pure magnesium. And of course we use magnesium as a fire starter. So that's the first thing you're thinking is, gosh, what if you scrape this against something? Is it going to burst into a 5,000 degree flame? No. Magnesium's actually a fairly safe material, except when it's in a powder form or in thin ribbons or something where there's a lot of surface area to weight. That's when you can ignite it. Plus, this isn't pure magnesium. It's been alloyed, and it's used in the aircraft industry, the race car industry, motorcycles, a lot of lawnmower components and decks, garden tools, things like that are magnesium. It's a great material, very common. It's like the 11th most common element in the human body, very safe. Doesn't have the toxic, in fact, people take magnesium supplements. Aluminum, on the other hand, is a neurotoxin. It can give you, some really bad side effects if you're exposed to it. You inhale it in a powder. By the way, it's also dangerous in a powder form. Carbon fiber is fairly inert, or as one viewer pointed out regarding some carbon fiber stuff I was working with, that apparently he said it doesn't show up on x-rays. So if you got a sliver or somehow had a piece of this under your skin, it might not be something you could easily see. But I'm digressing. So back to this magnesium. Let's take a look at what makes this kind of unusual. I'm going to fire up a scale here, and we're going to look at the weight distribution on this flashlight. And I'm going to go head to head with the standard aluminum Baton 3 Pro Max, because this is probably an up-and-coming material. It's probably going to have more to do with people getting used to it as a flashlight material than it actually being hard to work with. And the folks at Olight did CNC this. So if you CNC magnesium, it's got to be something that doesn't have any inherent dangers. So I've got this zeroed out on ounces. Here is the magnesium one. You can see this is 0.87 ounces. Pop that battery. Come with the same batteries. Here is the aluminum one. We've got 1.25 or 1.125 ounces, and it is noticeable. You can feel this magnesium one is lighter. If we go to the flashlight heads, I'll start with the aluminum one, which is 1.6 ounces, and the magnesium one, we've got 1.4 ounces, basically. It is noticeable. You can feel the difference between those two. Let's throw them back together, and what I'm going to do is do a heat dissipation test. By the way, on this particular Olight, the battery, the traditional bump on the top goes up. Some of the Olights goes down. So let's go ahead and fire these up under conditions, or under a kind of controlled conditions with a thermal camera viewing them, so we can see how the heat dissipates as these run. And for some comparison, I'm going to run a couple of other lights along with it, including here's a Warrior 2 or Warrior Mini 2, and I'll do the carbon fiber i3T EOS. This does take a regular AAA battery. So anyway, get my magnesium out of the way so we don't explode. By the way, if you use ferricium or ferro rods, these may or may not have magnesium in them. That's not how these things work. So it's not a magnesium situation. So I've got a snap-on pry bar here, iron pry bar, and that is to raise the tip, the lights off of the table, so the proximity sensors don't fire or don't trip and then reduce the output. So here's my layout. I can do it probably this way. I'm going to bring in a thermal camera now, line that up, and crack down this light a little so you can see this, turn this on, and hopefully that when that one fired when I put the battery in, it didn't change the temperature much. We'll see in a second here. These should be room temperature. They're the same. I have charged these, so you can see that does have on that shake awake, there's the green light there, and there's the green light there. So they are both fully charged. So this is what it looks like. I'm going to start up the two center ones, the two Baton 3 Pro Maxes at the same time, and then light up the others because those are more for reference. So here is this one. I can see my fingers. Here is this one. I'll move it over a little, and then you can see those two. Let me double check the temperature here. This one looks like 62 degrees. This one, 65 degrees, 64 degrees is the starting. Oh, there, 64, 67. So they're right in the ballpark, you can see. So let's go ahead and turn them on and watch what happens. I'm going to fire these both at the same time and then lay them back down. I'm going to double click this to put them into turbo mode. You can see the green light. So here we go. They're both in turbo, both laying down. Now I'll fire up this Warrior. You can even see it, and this guy over here. Kick that onto its high setting. So there we go, and what we're looking at primarily is the color change, because that's going to indicate how the aluminum and the magnesium dissipate the heat that's generated. Line these up exactly the same. If we go up near the front end, you can see we're at about 92 degrees. If I line that one up, and this one is 104 degrees, 105. And that one. So the aluminum one, what's interesting is this almost seems counterintuitive, but the better it dissipates the heat, the hotter it will be, which means it's dumping the heat. A lot of times, like with computers, if you've got a metal computer case versus a plastic computer case, the plastic is acting like a cooler, like a styrofoam cooler or a Yeti or something, and it actually is holding the heat in so it can get hotter. But if you can dump the heat, if you can get rid of that heat, then you can actually start to do more with the electronics in a smaller space. But if you end up holding the heat in, then it actually creates more problems that have to be overcome with larger housings, more heat sinks or less. So what are we working with here? The aluminum one, I've got 109 and I've got 115 on the new magnesium housing. And again, my shop here looks like it's staying about 68 degrees room temperature. It feels colder than that in here. So what I'm doing, hopefully, is showing you the significant difference between a magnesium housing and an aluminum housing. I don't think everything's going to turn to aluminum, just like I don't think it'll all turn to magnesium, like I don't think it'll all turn to carbon fiber. However, it's fascinating to see a company that has the kind of the background in lighting and basically the worldwide distribution to start pushing different materials, because we're going to end up seeing some pretty neat stuff. Personally, I'd like to see a bamboo flashlight. Of course, you'd have to run a copper insert down the side, but wouldn't that be neat to have a bamboo a bamboo flashlight? Anyway, let's see where we're at now. So here, I am at, if I go up to the top end of that, magnesium, that one's stabilizing 106. This one now about 100 degrees. You can see, hopefully, if I get that crosshair right there, 107. How does that compare? About 83 on the carbon fiber and about 75 on that Mini 2, Warrior Mini 2. Let's see where my hand now is actually cold as this color scales. Any other change here? About an even 107 is where it's stabilizing. Uh-oh, what happened? I wasn't touching anything, so it shut off. But anyway, I'm going to wrap that up. Maybe this is you guys telling me to hurry up. So that's what we've got with the, I want to drop my camera here. With these two, they are noticeably warm. Whoops. And this one's noticeably hotter. So this one is dumping the heat better. You can see the proximity sensors kicking in. Oh, by the way, that is one of the differences. I didn't mention that in this video, that the proximity sensor is less sensitive. So you don't have quite as many on and offs or throttling down as you're moving through, say, leaves or foliage or something. But anyway, so there it is, the brand new Olight Baton 3 Pro Max in magnesium. This is the beginning of another journey into not really exotic materials, but definitely new or novel materials for flashlights. So we've got carbon fiber, we've got aluminum, we've got stainless steel, and now magnesium. So maybe bamboo in the future. So anyway, let me know what you think about this. It's unique. It's the first time I've ever used a magnesium flashlight. And I hope my research is correct about the safety of magnesium. As far as I can tell, I went to the Magnesium Industries Council on safety, etc. I could find nothing that made this sound like it was any issue. Could be, except, we've all kind of grown up with these things, so that's what's imprinted into my mind. And anyway, so with that, let me know. Doc out.